The Clyde ecosystem has gone through a huge amount of change since the 1960s, with an enormous change in the community structure of demersal species. The reduction in many species has caused a reduction in species evenness, and the whiting are one of the ones that are doing better than other species within the system. So the gadoid biomass within the Clyde Sea is basically being maintained by the numbers of whiting. So there's a similar biomass within the area, fewer species, and of the species present, the tendency is for them to be smaller individuals and smaller species as well. The focus of my work in particular has been to understand the connectivity in life stages of this species whiting, which, as we said, is the mainstay of the biomass within the Clyde Sea. Specifically, I want to look at the connectivity between different life stages, O group individuals and age 1 individuals in particular is what I'm looking at the moment. We are adopting a technique where we use natural chemical markers within the otoliths or ear bones of the whiting. This allows us to sample from areas of the Clyde and areas out with the Clyde and use the natural chemical markers within the otolith to identify the location where the fish was caught, and then tie that with earlier points within the otolith. It's a similar method to natural tagging. We don't rely on a mark recapture protocol. We go out, we sample the fish, and we can use the elemental composition of the otolith, particularly in the first stages, the edge composition of the otolith from a known location. We can then tie that together with an internal component of the otolith to infer where that fish originated from. So far the research, as far as that part goes, is in a very early stage. At present, I can differentiate between the west coast, the wider Scottish west coast, and the Clyde Sea, and the Irish Sea also. In future, I would hope to refine this so that I can differentiate between the Clyde and areas like the Minches and offshore of the west coast, and divide the Irish Sea into the west and east sides, which seem to have aggregations of whiting therein. The practical applications of this study are understanding the connectivity between different life stages and between different areas is fundamental to trying to protect and understand what processes are maintaining the gadoid biomass in the Clyde Sea. Obviously, we've seen a massive change in the gadoid community, with some species doing better than others. So to understand why those species are doing better, it's fundamental that we understand where they're coming from, or indeed where they're moving to. From a management perspective, it allows us to identify areas of high importance. So it could be, for example, the Clyde is the absence of larger individuals of whiting are moving out with the area. So the dispersal from the Clyde to out with the Clyde could explain why there are no larger individuals within the Clyde. That's not necessarily due to solely, say, fishing pressure. So if we understand that there is this level of connectivity, then we can put into context other drivers which might be forcing the system. For the next year or so, I'll be writing up the PhD and hopefully submitting 4 papers maybe, so to get this research out there. And obviously there's no good at just sitting on my hard drive. It's there for other people to read.